seen some basic IPv6 addressing types, like how it looks and the classification, global prefix value, and then we have something called three types of addresses. Unicast. Unicast is again further classified into three types: link local address, global unicast, and unique local addresses. So, and also we have seen some basic configuration of IPv6 addresses on our interfaces. So we know this basic configuration. So before we start our lab here, so in our session here we are going to discuss about routing. So the routing concept is similar to what we learned in our basic CCNA topics, where we have learned how to configure IPv for routing, whatever the routing protocols we have used in our previous sessions. If you remember the major topic of routing in our CCNA and CCNP courses. So the concept of routing remains the same. Like if I talk about static routing, whatever we learned, static routing, manually administrator has to configure the route for the destination. Everything has to be configured manually, and automatically it will not change the route unless you change it manually. If a route decided by the administrator goes down, administrator has to manually change the alternate route. So whatever the theoretical part we learn in our basic routing concepts, it remains the same. Now the only difference in the routing part here, if you talk about an IPv6, is the most of the part will remains the same. Almost the commands also remains the same. Wherever we use IP, we need to use IPv6. So here we are going to see how to implement these routing protocols or different types of routings in IPv6, and what is the syntax to configure them. Like we'll be seeing static, as well as we'll see the default routing for initially, and then we'll move to the next protocol called RIP-NG. So if you remember RIP protocol version 2 we used, we got RIP version 1 in IP version 4, we got RIP version 2. Now here we call it as RIP-NG. So RIP next generation protocol. So we call it as the RIP-NG here. So whenever you see RIP-NG or RIP for IPv6, you have to understand we are implementing RIP for IPv6. And again, the features of RIP will remain the same. Maximum hop 16. So maximum is 15, 16th hop is unreachable. And the best path will be calculated based on the number of hop counts. Whichever the route is having the least hops, that is the best route. Administrative distance value will be 120. All the points remains the same. So we don't really need to learn any theoretical part relating to these protocols. Only the thing we need to learn here is how to configure RIP for IP version 6. Similar way, this is something we don't do in our CCNA. So it is something covered in your service provider track. So we don't do any ISS protocol here. So we are going to ignore that ISS for IPv6, but still IPv6 ISS also support IPv6, and then we call as OSPF. Now whichever the OSPF we used in our IP version 4, we call as OSPF v2. So OSPF v2 means we have to understand it's for IP version 4. And if anyone say OSPF v3, or if a question says configure OSPF v3, you have to understand we are going to configure OSPF for IP version 6. And again, the concept of OSPF for IPv6 also remains the same. Like if you remember, we discussed some 7 stages, remains the same. The concept of areas remains the same. The concept of DR, BDR, if you know. So the concept of stops, anything, whatever the concepts we learned in our OSPF part, everything remains the same. So there's no change in that. Okay, only the difference is the configuration part. Okay, so similar way, I can say the next part, BGP will be seeing in our CCNP more in detail. So we don't do much into BGP protocol, but still we call as MPBGP, multi-protocol BGP features. And then also we'll see EHRP for IP version 6. Okay, so the major task here we are going to do is we are going to do some configuration of different types of routings. Okay, so let's get into the lab here. So if you remember, we already did some basic configurations in our previous class, and we know how to configure IPv6 addresses on the interfaces. So still I'll just quickly do these things. I got 2 routers already. They have a connection similar to what I have in my topology, and you can see show IPv6 interface brief. There is no interface configured with any of the IPv6 addresses. So I'm going to do the basic configuration as per my diagram. IPv6 address FC00 on the LAN interface 11::1 with /64 subnet mask. And similar way, I'm going to do the similar configuration on router 1 serial 0 interface, that is 2001 12.12.12::1 with /64 subnet mask and no shutdown command. The same thing I'm going to do on the router 2 as well. So basic configuration, you can, if you're doing the lab from our previous class, if you remember, we did these things already. You can directly continue with that particular part, or else if you have stopped your labs, you can even start from the basic by doing some basic initial configuration. So this is something, I'm just using some simple basic routing here, but even if you get into some advanced routings also, the configuration part remains the same. So the major task here is we are going to learn how the commands or the syntax comes in our IPv6 configurations when it comes to routing protocols. So let me finish off with my configuration on router 2 FC00:22:22:22:22 with /64 subnet mask. So you can use any of the IPv6 addresses, not compulsory to be use similar way what I used here, but as per my manual, I have been using these addresses. So you'll find all these labs documented step by step in my lab manuals. So, and then 2 with /64 subnet mask, done. So just to confirm, just to ensure that I'm able to ping to my opposite interface, I'm going to ping to the opposite interface, that is 1. So let me do some troubleshooting here. So show run interface S1/0, IPv6 address on the router 1. If I check on the router 2, show IPv6 interface brief 2001:12.12.12:1. Okay. So let me try to ping once again. Yeah, it's pinging. So it's just a matter of convergence. It takes some time for the links to come up. So now both the LAN and the WAN interface are pre-configured with some IP addresses. Just now I configured that. Now what I want to do is I want to implement static routing in this. Okay, so the first step, we are going to see how to configure static routing in case if it is 2 routers, 3 routers, 4 routers, whatever the size of the network. So similar configurations. So if you remember, the commands are almost similar what we did in our IPv4. So what is the command we use in IPv4 static routing? We use iproute command. Let me type down here. If you're using IPv4, we need to say iproute, and then we say destination network ID, right? So, and then we say subnet mask and then next hop IP address. That is a command which we use in our IPv4 routing. Now the similar commands we use here, but only the difference is we need to say IPv6 route here. So let me write down here for IPv4 we use IP route in the config mode, and then we say destination network ID, destination subnet mask, and then next hop IP address. This is what we do. In case of IPv6 also similar way, wherever we use IP we have to replace with IPv6. So IPv6 route, destination network ID, destination subnet mask, and then next hop IP address, or even you can tell the exit interface also depending upon the requirement. So I'm going to say here IPv6 route, my destination network ID is as per my diagram here. If you see from the router 1, I want to ensure that the router 1 should be able to connect into the LAN. So which means my destination network ID is this, and the subnet mask is always /64, so it will be /64. So we're not writing in the form of 255s. In IP version 4 we write 255.255.255.0, whatever it is, but here we write in this format /value, and the next hop IP address is 2001:12.12.12:2. So I'm going to type the same thing, FC00:22:22:22:22. That's it. Network ID means, first 64 bits are network, and remaining I'm just writing as double colon. So double colon represents all or zeros, remaining all 4 portions are zeros. So if you remember, we can write all zeros as double colon, and then writing the subnet mask without giving any spaces /64, and then the next hop IP address is 2001:12:12:12:2, the IP address of the router 2. Done. So no warning messages, no error messages means the command is correct. Now if I verify show IPv6 route, so if you remember, generally we use show IP route command to check the routing table. So I'm going to say show IPv6 route static, or just it is just going to show only static routes. You can see there is a static route created with administrative distance of 1. The output looks similar, only the difference is we have IPv6 addresses here. So if I say show IPv6 route, so you'll see connected interfaces, nothing but connected network. L represents the local interface. L means it's a local interface which defines the exact IP address on that interface. Okay, and then this is the static route which we just created. So the same thing we need to do on the router 2 as well. So on the router 2, I'm going to IPv6 route. So the next hop destination network ID is this, and the next hop address is 2001. This one is the next hop address. So let's try to write down IPv6 route FC00:11:11:11/64 network ID with subnet mask and the next hop address, or even you can just write exit interface also if you're using serial interfaces or point-to-point interfaces. So not compulsory next hop, it can be exit interface also, but it's up to you as per the requirement. So now if I verify my routing table, I should be able to see the static route created on router 2 for router 1 LAN interface. So now finally I need to ensure that I should be able to ping between the LAN interfaces of both the routers. So now from here I should be able to ping to this interface. I don't have a real LAN network here, but still the LAN interfaces should be able to ping to each other. That's the final confirmation. So either you can check from router 1 or router 2. So I'm going to check from router 1 and trying to ping to the LAN interface of router 2. I should be able to ping. In case if I'm not able to ping, then there is some issue. Now there is one thing I actually forgot to tell you. So the main reason here is I just missed one thing here. So you have to make sure that you have to enable IPv6 unicast routing before you do anything. That is something which is very important. So because in general this command is similar to your IP routing. You know, in IPv4 we have a command called IP routing, and by default IP routing is enabled by default. We don't really give IP routing, but if you want you can disable this by giving a command called no IP routing. So IPv4, IP means whenever I say IP, you always need to understand we are talking about IPv4, and whenever I say IPv6, you have to understand we are always talking about IPv6. Okay, so now in IPv6, in most of the IOS, I can say almost in every IOS as of now, the IPv6 routing is not enabled by default. It is disabled by default. So you have to make sure that you have to enable IPv6 routing before you use any of the routing protocols. Which means to enable, we have to use a command called IPv6 unicast routing. So this is the command which we use to enable IPv6 routing here. Okay. So this is something which I forgot. I think so. That is the reason we are not able to do that. So let me enable that. Okay. So IPv6 unicast routing. You can see here. Same thing I'm going to do on the router 2 as well. IPv6 unicast routing. Okay. So let me try to ping from router 1 more time. Last time I was not able to ping. This time I'm getting some unreachable messages. So now the problem was, if you remember, we were trying to troubleshoot these things. I was not able to ping. So now I'm able to ping. What I did is, in my program which I'm using GNS, so actually there is no connection in the LAN. In general, as per the normal thing, this is a LAN interface which we are using, which is FC00, which we are using FC00 111111, whatever the IP address here. Okay, and the LAN interface which we are using is FC00 and 22 we are using here. So the problem was the interface which is connecting to, there should be a connection actually. So in the real network it is actually connecting to some switch, and from the switch there are some multiple users in the LAN. So here I'm using this program GNS3, where there is no connection actually. So when there is no connection, automatically this interface will show as up and down. I'll show you this here. I did not make any changes on the router 2. If I just go to my interface, show IPv6 interface brief, or show IP interface brief, you can see the status of the interface is up and down because there is no physical connection on it. So now there are two possible solutions for this. Either you can add a switch, you can just drag and drop a switch here. You can just, this is just a unmanageable switch, and you can provide a connection from the router F0 by 0 port, which I configured the IP address, and you can provide a connection. So when you do this, automatically now, if I try to verify the same command, show IPv6 interface brief, now you can see the interface comes up here. Okay, so either you can do that, or there is one more possible solution. As it is a lab scenario, I can also use a command called no keep alive. So no keep alive, what it will do is it is going to disable the keep alive mechanism, because by default in between any two networking devices there is a default keep alive mechanism. So now here I got a device connected on this particular port, so they both are going to send and receive something called keep alive messages for every 10 seconds. If you want to verify this keep alive messages on the Cisco routers, you can use show interface command S1 by 0. So possibly this particular part I discussed in my CCNP documentations as well. Okay, but here I'm not connecting any device here. So if you want, you can provide a connection, or you can just give a command called no keep alive, which means even though there is no connection, simply make the interface up, because in our labs we are using it for testing purpose, and we're not using the real LAN network. So don't really use this command in the real production networks. If you do that, even though if the connection to that particular device goes down, still it will show you as a up, which means you will not be able to communicate, but the router will show it as only up. Okay, so don't try to do that in your real production networks, but here I can use any one of these solutions. So because adding extra devices really make my topology a little bit more complicated, so I don't want to do that. So I always prefer to use this no keep alive command as a lab specific command here. Okay, so some basic troubleshooting in general. Actually, it's not a big troubleshooting we do here, because static routing is something which we are well aware of, static routing. And you can see now it's pinging, so there's no problem. So now even it can be 2 routers, 3 routers, 4 routers, the concept of static routing remains the same what you learn in our IPv4. Only the thing you need to understand is how to configure in IP version 6. So the command is also similar. So now the next task, what I'm going to do is I'm going to remove these configurations. Okay, so whatever I did, I'm going to remove the static routing, and then I want to ensure that router 1 and router 2, these two routers, should be able to communicate with each other via default routing. So default routing, we know that it is generally used at the end locations connecting to service provider, or if you have a one common next hop, we use default routing. And the command generally we use is IP route 0000 0000 and the next hop IP address. Now in IPv6 also you have to do the same thing. We need to say IPv6 route. Now instead of all zeros, we generally use 0 double colon. So 0 double colon represents all zeros, and the subnet mask is represented with /0 here. And then we need to write the next hop IP address. So either you can write the next hop IP address, or you can write your own exit interface. So this is how we write here. So let's move on. So in this, now what I'm going to do is I'm going to remove this static routing. So removing the static routing is very simple, just we need to add no command before that. So let's do that and then implement our default routing here. So if you remember the command which we used, this is the command which we used last time. So I'm just adding no before to that. Similar way, I'm getting into router 2 as well. I'm going to remove that command what I added last time. Okay, so I just modified this with the next hop IP address in between when I was troubleshooting, so it's okay. So I just removed it, which means now if I verify, there is no static routing, there is no dynamic routing. So now I want to ensure that router 1 and router 2 both should be able to communicate via default routing. So I'm going to say IP route, IPv6 route. Instead of defining any next hop, any destination, I'm going to simply say as zeros, and the subnet mask also /0. So there should not be any space in between. Now you have to give space, and the next hop address remains the same what we added before. This is the next hop. Done. So now if I verify my routing table, show IPv6 route, you can see this is also one type of static route, but for unknown destinations via the same next hop address. A similar way I can go to router 2 as well, and I can do the same configurations on the router 2, or you can just use static routing on the other end. So IPv6 route, and I'm going to say FC, so 0 colon colon /0, and the next hop. Generally don't use default routing on both the sides, not really recommended because it will create the loops. So either you can use static routing also. Okay, and the next hop address is, I can just say my exit interface S1/0 interface. Okay, so now if I try to ping to the LAN interface of router 1, so you can see the reply is coming. So don't use default routing on both the sides. It's not recommended, because here in the lab purpose we can do that because we have a LAN interface here and interface here. Okay, so we can easily ping to that. Suppose if you try to ping to say some other address which is not present, let's say I'm going to try to ping to FC001234 address, some address, something which is not at all existing. So now the router 1 is going to send to router 2 because of default route, and router 2 says I don't know where is 1234, and but I have default route, I'll send back to router 1 and send back to this one. So this is something which we don't really want to happen. That's the reason we don't use really default routing. Even when you use default routing in our production networks, we always use a default route towards the ISP, and ISP is going to configure a static route towards the service provider. So you know these concepts of default routing from the basic CCNA studies which we did. Okay, so I can even show you that if I just try to verify, I can try to ping, or I can try to trace some address which is not existing in our network. So there's no 1234 address and then colon colon 1 I can say. Okay, you can see it's looping here because it goes to router 2 and then come back to 1 and then come back to 2, like that. It will reach the maximum time till you TTL value, and finally it will drop over there. So I really don't suggest you need to look after these type of scenarios whenever you are doing, because you may come across this type of scenarios when you get into production networks because of some default routes or because of some routing issues. You may create the loops. Okay, so you need to be a little bit more careful in this type of scenarios, especially when we are using default routings. In dynamic routing we don't have these issues because dynamic routings are a little bit loop free routings, but we need to be careful when we do redistribution at that times. Okay, so now the next part we'll be seeing about how to configure dynamic routing protocols like OSPF, we'll see EIGRP, and we'll see RIP. These three protocols we'll see as per our CCNA syllabus. So probably we'll be discussing on these three protocols in our next video. We'll see how to configure these dynamic routing protocols.